Carbon has 3 common isotopes used in organic chemistry: carbon-12 with 6 neutrons, carbon-13 with 7 neutrons, and carbon-14 with 8 neutrons. Think of an atom like a small ball with a center called the nucleus that contains protons and neutrons. All carbons have 6 protons, but the number of neutrons can change, and that change gives us different isotopes. Carbon-12 is the most common and stable. Carbon-13 is also stable but rarer and useful for tracking molecules because it shows up in certain instruments, and carbon-14 is radioactive and used to date once-living things because it slowly decays over time. When chemists study molecules, they sometimes replace a normal carbon with carbon-13 to see where atoms go during a reaction, because instruments can detect that extra neutron. Carbon-14's extra neutron makes it lose particles gradually, which tells us how old organic samples are by measuring how much remains. Students often think isotopes change chemical behavior a lot, but chemical bonding is ruled mainly by electrons, and isotopes have the same electrons, so reactions are usually very similar, and the tip is to focus on electronic structure for reactivity. Another common mistake is believing carbon-14 is used in routine chemistry experiments, even though its radioactivity requires special handling, and the solution is to use carbon-13 for tracking and reserve carbon-14 for dating with proper safety. Some learners confuse atomic mass with isotope identity, so remember isotope names tell you how many neutrons are present and that the mass is roughly the sum of protons and neutrons. Visit www.gumballdegree.com to find more videos and resources on isotopes and organic chemistry.